So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as data storage in GIS. So till now in this database management, we have learned about different types of databases, different components of databases. So like in the previous lecture, if you remember, we have learned about the different components of DBMS. So different components of DBMS like hardware, software, people, and the procedure and the users, that all we have learned in the previous lecture. Now in this today's lecture, we are going to discuss about the storage in GIS. So what type of data which is going to store in the GIS, and what are the different formats we are going to learn today. What are the different formats will be stored in the GIS process. So let us start with today's lecture. So before that, let us go through the contents what we are going to learn today. So that is data storage in GIS, data storage retrieval and management, storage media and storage formats. So this all we are going to learn today. So first of all, let us understand what type of data we are going to store in GIS. So data storage in GIS, if you remember in the previous lectures, every time we have discussed about the spatial and non-spatial raster vector. So these are the very common words whenever any type of topic we learn it. So these are very common words we will come across. So a raster, vector, spatial, non-spatial, these all data will be stored in the database of GIS. So database of GIS, when it is stored, then only the retrieval of the data and management of the data or any kind of analysis is possible based on this type of the data storage. So data storage in GIS, so the different types of information required for GIS to require storage which allows the information to be updated, queried or further analysis by the users. So different types of information, when you talk about different types of information, we have two types of information here, that is spatial and non-spatial. When you always talk about the spatial information is about the surroundings, whatever we see around us, all the spatial information, all the geographical information that we see around us, that all kind of information comes under the spatial. So when you talk about a building, that is a spatial. When you talk about a road, that is a spatial. When you talk about an area, that is a spatial. So any kind of information which is in the form of point, line and polygon. So these all types of information that we call it as spatial information. So these all information will be stored in the database where we can easily update the information. Once you store the information, the updation of the data is easy to do. Otherwise, when the data is not fed in the system, when the data is not fed in the database, then the updation will not be possible. So whenever we have the old version of the data, then later whatever information we want to update, we can just update the information. For example, just a simple example we will discuss here, like a Word file is there. So in a Word file, we just write any information and later we save it. So if you want to say update the information, just we open that information which is already there in the database, and later we can just add the information, we can update the information to it. So that's how the database here in the GIS, when you have a spatial information here, when you have a non-spatial information, then information will be saved in the database, and later whenever the retrieval you want to update the information, or if you want to any type of query you want to do, any type of analysis you want to do, it is possible to do with the help of the stored information in the GIS process. So there are two types of information to be stored as we have discussed just now. There are two types of information we generally store in the GIS, that is the spatial and the attribute data. So spatial data, as I told you just now, whatever we see around us, so that all comes under the spatial information. So a table, a pen, a building, a tree, or else a water body, or else roads, whatever you will see around you which has a image. So that kind of all the information, the physical information, whatever you see around you, that all comes under the spatial information. Now what is attribute information? Attribute data, or we call it as this attribute data, we call it as even non-spatial. Non-spatial, if you remember, we have already discussed in the previous lectures also. So this is also known as the non-spatial. Attribute is non-spatial. Now, what is non-spatial is? The non-spatial is the information what we add to the spatial is called as non-spatial. So that all information will be stored in GIS for the updation purpose, query purpose, or analysis purpose. If you want to do updation, we can do. Query, if you want to do, we can do. Analysis part like overlaying of the map or extracting any information, theme-wise information to be extracted. That all information can be done with the help of this storage in the GIS. Okay, so here spatial data, when you talk about spatial data, is usually stored as themes, layers, and coverages. So when the spatial data which is saved in GIS storage device or database, that will be stored in the form of either themes, either layers, either coverages. So all the informations, when you talk about theme is like a different individual type of information, spatial information. When you talk about forest, so this theme will be only forest. So around in the entire map, the forest information will be saved. So entire forest information is there. So now if you talk about any buildings, so here you have one more theme as buildings. Okay, so these are all buildings. So these are all layers, or we call it as themes or coverages. We can store the data in the GIS. Now, data storage, retrieval, and management. How do we store the data? How do we retrieval and management? So the different types of information required for GIS requires storage, which allows the information to be updated and queried for analysis by the users. There are two types of information stored, spatial and non-spatial. Like when you talk about the georeference, spatial data is displayed in a GIS in its proper place in relation to the other spatial data. So the georeference data, when you talk about this georeference data, what is the georeference data? Georeference data is always the reference data which is assigned the coordinates to each location. So once you have a map, suppose this is your map. So if you assign the coordinates to each point of this location, so suppose we assign 4 coordinates here, coordinate 1. So here latitude, longitude, okay, point 1. So we call it as GCP point 1, 2, 3, 4. So once you assign this GCP points to all the coordinates, all the locations, then you run this georeferencing process. The total data will be georeferenced based on the assigning of the latitude and longitude to that. So it has its exact location present in the map. So that georeference spatial data is displayed in GIS in proper place in relation to other spatial data. So once we georeference, for example, we have 2 maps here. So this is one map and the other map is adjacent to this. So this is called as map 1. This is called as map 2. So 1, 2. So this data should be georeferenced. If you want to align these 2 maps parallelly, like adjacent to each other, then both the maps should be georeferenced. For example, you have to assign the GCP point here, okay, to GCP 3 and GCP 4. So 1, 2, 3, 4. So 4 points we have assigned here. Now same thing we are going to assign in the second map also, GCP 1, here GCP 2, here GCP 3, here GCP 4. So now you can see here GCP 2 here and GCP 1 for the second map is common. So this point is common. So the values for GCP 1, GCP 2 in the first map and the value for GCP 1 in the second map will be common. So once you assign these values, as automatically this map will be attached to each other. So it will be adjacent to each other and it will be automatically fit to its location. So as it is called as GIS in the proper place in relation to the other spatial data. So it will be in its proper place once the georeferencing of the data is assigned. So this all georeferencing is stored in the GIS storage, the GIS database, where we can just assign this information and we can retrieve this information whenever we need. So once the georeferencing is done for all the maps, then only the data is adjacent to each other and we can see all the data together. It is placed in its proper location. So because of the georeference information attached to the data, an example could be the latitude and longitude in the decimal degrees. As I just now said you, latitude and the longitude we have to assign to each point of this map. So once we have assigned the latitude and the longitude, the map becomes georeference. So once the data becomes georeference, that means the data is already fixed to its location. So if you want to assign, if you want the third map also what to be fixed here, what we have to do, we have to assign the coordinates again to this all 4 points. So here what will happen for the third map, the second point of the second map and the first point of the third map will be common. Okay, point 1, 2, 3, 4. So like this, if once you assign the geographic coordinates or latitude and longitude and georeference the data, the map will be fixing to its location and that will be stored in the database. Okay, so the latitude and longitude of the school is embedded in the file, so it will be displayed in the GIS and its proper location in relation to other features in the city. So once it is fed in the data storage, it will show you the proper location and all the information will be displayed in the map. So themes can be anything that are currently located on the traditional paper map, such as roads, rivers, cities, wells, forest boundaries. So these all themes after the latitude and the longitude, after the georeferencing of the map, which will be stored in the GIS process. Then later what we have to do is we have to assign the themes to the whatever information is there in the traditional paper map, such as road. So road is one theme. So this is one theme, theme 1. River is one theme, this is theme 2. Cities are one theme, this is theme 3. Okay. Wells is theme 4. Forest boundaries, theme 5. So we have total 5 themes here. So these all 5 themes will be separately located in the paper maps or different coverages. Okay. So school district boundaries, etc., and they all are georeferenced. So now attribute data, when you talk about attribute data, it is the information about an object or a feature. An example could be our school. So if you talk about the information about the attributes, so school physically it's a spatial. Now if you write the name of the school, okay, name of the school or name of the or college, that becomes attribute. Okay, attribute. So what is the name we assign to this? If this is the school, so if you assign the name to the school or college like IARE, if you assign, so this is called as attribute, or we can call it as non-spatial information. Okay, non-spatial information or spatial information. Okay, so these are all about this or spatial information. So attribute, non-spatial or spatial information we have to assign to the spatial data. So its names, location, what district, how many children attend each year, etc. This all comes under the, this all information comes under the attributes. Okay, this all information comes under the attribute information. Okay, so these are all attribute or non-spatial information. Okay, non-spatial information. So this is how we just we are able to get the retrieval of the data. Once we feed the information in the GIS software as a spatial and attribute, the information will be easily retrieved by this type of information. Now storage media. What are the different storage media where the data is stored in the software or in the system? So storage media, digital data is stored in the variety of physical media depending on the how quickly the data needs to be accessed. So it depends on the physical media, depending on the how quickly the data needs to be accessed. Based on that, the data is saved in the storage media. So how much data needs to be stored, whether the data needs to continue to exist or not, that all information based on the requirement, it is saved in the software. So when the digital devices turn off or rebooted, that all information. Now these are all different devices, we can say the data can be stored in the system. So what are the different storage devices here we have is random access memory, RAM is there. We have a magnetic hard disk, we have a flash memory, we have a magnetic floppy disk, magnetic tape. So these are all different kinds of storage devices where the data can be stored or it can be saved. Okay, so when you talk about RAM, what is a RAM here? So RAM stands for the random access memory and it's one of the most fundamental elements of the computing. So RAM is a temporary memory bank where your computer stores the data. It needs to be retrieve whenever we need the retrieval of the data. It will be easily retrieved from this computer system. So RAM will be there in the computer setup or GIS setup, wherever we do the setup, that all computer setup will be there in the RAM. So there we can just temporarily, the data will be saved and in your computer stores, and whenever we want to retrieve the data, it will be quickly retrieved. Okay, so RAM keeps the data easily accessible, so your processor can quickly find it without having to go into the long-term storage. So RAM is having such a possibility that easily it can be accessible. Your processor will can quickly find out the information wherever the data will be saved in the computer system. Long-term storage to complete the immediate processing and task. So RAM is just like a memory, which is a temporary memory, and it will help the processor to run very fast, and it will help the computer system to find out the data wherever the data is saved in the computer system. Now, magnetic hard disk. When you talk about the magnetic hard disk, so magnetic hard disk, commonly known as the hard disk drives, HDDs we call it as, are a type of data storage device that uses the magnetic storage to store and retrieve the digital information. So this all information will be stored in the magnetic hard disks like HDDs or hard disks, whatever we have. So this type of storage device will be using the magnetic storage, and it can store the data easily. It can retrieve the digital information out of it. So they have been a staple in the computer storage for decades and are widely used for their high capacity and relatively low cost per the gigabyte. Now, flash memory. When you talk about the flash memory, what is a flash memory? So, flash memory is a type of non-volatile storage technology that can retain data without power. So, flash memory is such kind of memory which will have a non-volatile storage. It has a non-volatile storage technology, and they can retain even the data without the power. If power is not available, also the data can be maintained with the flash memory. So it is widely used in the various electronic devices for its durability and speed and capacity. So it's a non-volatile storage, and because of its speed and durability and because of its capacity, it is used in the various electronic devices for storing the data. So here's a comprehensive overview of flash memory. Now, when we see about the magnetic floppy disk, we have a magnetic floppy disk where one of the earliest forms of portable storage media used in the personal computer. So magnetic floppy disk, nowadays it is not at all used in the computer system. So it was the oldest or the earliest forms of portable storage media used to be saved in the personal computers, and that was having a very less memory, and the information was saved because before we were not having this hard disk devices, CD devices, flash devices. So before it was saved in this kind of magnetic floppy disks where the data is saved in this personal computers. So though largely obsolete today, they played a crucial role in the development of data storage technology. Now, magnetic tapes. So what are magnetic tapes? So magnetic tapes are type of the storage medium that use the magnetic coating or the thin flexible strip of plastic film, and they are widely used in the past for the storing the audio, video and computer data. So previously the magnetic tapes were very much used for the storage devices, storage media, and it has a magnetic coating on a thin flexible strip where the plastic film is there. There we can just find out the information. There the data is stored in that kind of tapes, and they will be widely used in the past for storing the audio. So in the past, in the previous years, in the previous days, when we don't have this pen drives or flash drives or hard disks, then we used to store all the information in this magnetic tapes. So information was stored in this magnetic tapes while storing the audio, video and the computer data. So magnetic tape was developed in the early 20th century with significant advancement made during the World War II. So when it started in the early 20th, from that time onwards, the magnetic tape is used for the advancement, and it is used for the storage of the information in the software. Okay, next we have some storage formats. So storage devices are we have seen. Now we understand about the formats. What are the different formats where the data, the GIS data or the spatial data and non-spatial data can be stored. So we have geospatial data can be stored in the number of different types of digital files on the physical media described above. The following are the file types you can commonly encounter when performing the basic GIS. So what are the files we will see? We have a graphical maps. Okay, so this is one of the format where the data is saved. Okay, so geospatial data can be stored in the number of different types of digital files. So the data which is in the paper formats that can be converted to the digital files and on the physical media described above, and the following are the file types you will commonly encounter when performing the basic GIS. So files are like graphical maps, are visual interpretations of graphical areas, often created using the variety of tools, techniques to convey the spatial information effectively. So these are the graphical maps which we can see here. So graphical maps means all the information like all the geographical information will be saved in this kind of map. Like when you go through this map, it will tell you about the whole information about the spatial data and the non-spatial information. Like this, you can see the world map of it, right? So here you can see the world map of some area it is shown, and along with that information, the data will be shared and saved in this kind of formats. Okay. Next, geospatial data can be stored in a number of different types of digital, physical media. Okay, now CSV files. So what are the CSV files? So geospatial data can be stored in the simple table formats like comma separate variables, CSV files. So as columns of latitude and longitude associated on each row with specific attributes at those latitudes and longitudes. However, this is largely limited to the points rather than the area. So what are the CSV files? CSV files are the comma separate variable files. In this, we will save the data like latitude and longitude associated with the rows and the columns where the data can be stored. The attribute information can be easily stored in this kind of data. Like this CSV file will look like this, where you can store the latitude and the longitude information, the street information, the city information, all the information which is like attribute information. Attribute information will be stored in this kind of data. Okay, so these all are having the information of the spatial information will be stored in this type of CSV files, which we will link to GIS. Okay, so entire information related to the latitude, related to the longitude, streets, roads, cities, houses, all the information, all the detailed information which we are going to retrieve, that all information is stored in this CSV formats. Okay, so this kind of formats is called as a CSV format. Now shape files. This is very important storage. We can say how these shape files are saved in the GIS. So what are shape files? If you understand, if you remember what are the shape files. So shape files are three types we have, right? We have point, we have line, we have polygon. So we have three types of shapefile: point, line and polygon. So what is a point here? Point means the information which we can see in the map, which is in the form of the point format, like locations. So all the locations will come under points. So locations like if you want to locate a college building, okay, college building, or if you want to locate a pole, or if you want to locate a tree. So these are all information which we can see in the point. And line is all the linear features like roads, canals, rivers, okay, all these drainage patterns. So these all informations will be stored in the form of a line. Now what about the polygon? Polygon will be stored as an area like forest boundary. We have a village boundary, and mandal boundary. Any kind of boundary we can say it will come under the polygon, or some water body. Okay, water body which is closed. So these type of files are called shape files, point, line and polygon. Why we call it as file? Because it has a shape, right? So it has a point shape, it has a line shape, it has a polygon shape. So along with this point, line and polygon shape, it carries the entire information. So what is this shape is called spatial. Now it will carry the non-spatial information. So non-spatial information is what? The name of that. Non-spatial is the name of the spatial. Okay. So the information about the spatial, non-spatial. So the shapefile actually a collection of at least 3 and usually more separate files that store the location data, the characteristics associated with those locations and other information about the data. So some common files associated with the shapefiles include listed by the file extension. So these files are saved in the file extensions. So as you create a shapefile, so first thing, if you are going to create a point, so this is your point. So this is your shape file. Okay. Now what will happen? So once you create this shape and you start assigning the information, so what will happen? There will be different extension files will be created. Okay. Extension files will be created like .shp. This is the files we create. .shx, .dbf. So these 3 files will be created immediately once you start creating the shapefile. So once you put a point and you start creating that shapefile, the .shp, .shx, .dbf, these 3 files will be created. And later once you start working with this shapefile, the other files extension will also be created, which you can see here. So let us understand what is that .shp. This is .shp contains the feature geometry. So it will contain the feature geometry like either point, either line, either polygon. So if you have assigned a point, it will contain the geometry as point. So if you have assigned a line, so it will contain the geometry as line. So if you have assigned a polygon, it will contain the geometry as polygon. So these 3 things will be created immediately once you create the feature geometry. Then .shx, an index file that indicates where specific features are in the .shp file. Specific features, what are the specific features will be created in that .shx. .dbf, it's a database file. Okay, database file for database file of attributes associated with each of the shapes in the .shp. Then after the later the files will be created .prj. When you start working with this shape file, the files will be created as .prj, .cpg and .qpj. So these 3 will be created after you start working with that particular shapefile, either point, either line, either polygon. So the coordinate system and the projection used by the feature geometry is optional. And .cpg, so this is PRG is a projection coordinate system. .cpg is the character encoding used by the attributes. And .qpj is a coordinate system and projection in the format used by QGIS, ArcGIS, or any kind of software we are going to use. We are going to create the this shapefiles. This will work with all kinds of shapefile. So that all depends on the what type of shapes we are going to use, what type of shapefile we are going to use. That all depends on this kind of particular file. Okay. So this is the very important part. Like what you say, storage formats are graphical maps, CSV and shapefile. So shapefile is the very important in the GIS process when you are going to save the files, and this all data will be saved along with the shape. The attribute information also will be saved in this shapefiles. Okay. So I hope you understood the data storage in GIS. So how the data is stored in GIS, either in the spatial data will be saved in the graphical maps, non-spatial data will be stored in the CSV files, or if you talk about this shape files, when you start creating your vector information, so the shape file will be stored in the form of the shape files. So yes, shape files has 3 to 6 extensions: .shp, .shx, .dbf, .prg, .cpg and .qpg. So this is how this data storage in GIS will work for the further retrieval or the analysis process. Okay. So these are few references you can just go through to find out the more content about it. You can just go through this book, MMG Ready book. Every lecture I'll be telling you about this book. This is very good book for this remote sensing in GIS. And you can go through this links to find out the more content about this data storage in GIS. Okay. So I hope you understood about the data storage in GIS. So That's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.